So in this problem, we're given the results of a LaGrange multiplier problem. And what we find out, this is just a summary, for a new line of products, a company has a budget of $3,400 and they have two variations in this line, widgets and doodads. In order to maximize their revenue, they convert their numbers to hundreds of dollars, and then they optimize the function r of xy subject to the constraint g of xy equals 34. So this is the $3,400 converted, so this is 34 hundreds of dollars. So their analysis returns the following: that r of 244, 412 equals 540 with a lambda of 2. So let's talk about this line first, and then we'll talk about what we're trying to solve. So what does this mean? Well, this means if they produce 244 widgets and 412 doodads, they found that they won't maximize their revenue, and that they'll get 540. Now this isn't $540. Remember, this is in hundreds of dollars. So their max revenue would be $54,000. Now we have a lambda of 2, and it's important to understand what's going on with the lambda. So the lambda, also this is in hundreds of dollars. So we got a lambda of 2. Now what the LaGrange multiplier gives us is how we would expect our optimal value to increase if we increase our constraint by 1 unit. So this means that we would expect to see our maximum revenue go up by about $200 per, now remember the input was in hundreds of dollars, per $100 change in input. Or we could actually do this as $2 per dollar, which actually makes it very easy to use, because right here, look at what they're increasing their budget by. They've got a change in their budget of $150. And according to Lambda, at this current level, if they were to increase their budget, we would expect their revenue to roughly go up by $2 per $1. So if they have an increase in a budget of $300, we would see roughly an increase of revenue of $300. That's coming from taking the additional budget and multiplying it, in this case, by our lambda. Now we had to pay attention to the units on our lambda in order to get this relationship. That means our new revenue, if our old revenue was $54,000, our new revenue would be $54,300 approximately. Now, the lambda is an instantaneous rate of change, so the further we go from this budget of 34, so say 35, 36, so if we were trying to say a budget of $4,000, we probably would want to recompute our whole problem, because our approximation is going to be off by a lot more at that point. But for something this close, we just increased really our budget to, if we convert this into hundreds of dollars, 35.5, we really only increased our budget by 1.5. So I think it's pretty reasonable we use our lambda for our approximation there.